Hi there, welcome to video 3, chapter 5, proportions. We'll get into now what happens if we have an unknown and how we can find it. And we will get into some applications and problems, and we'll see all the different types of problems that we can solve using a proportion. So we're at the bottom of page 9 in your notes. If you're not sure, and I've got to get my pin selected, it went away. Let's see, there it comes, right there we go. All right, we're on page 9 in your notes. At the bottom slide, you have this. So if I'm going to solve this proportion, in the last video we finished by learning that if you multiply cross products, they're equal if it's a proportion. So if I multiply cross products here, take a look at this. That means 6 times x. I have 6 times x. If it's truly a proportion, 6 times x has to equal whatever 3 times 4 is, and 3 times 4 is 12. There you go. This is how we can use it. Now, we learned earlier this year when you have a variable, that becomes the number 1. Remember that trick? You divided it by 6, you got to divide that by 6, and x equals 2. So you might have seen that from the beginning, but I wanted to start with a simple one just to show you that it's that rule of cross products that allows us to do that. It's not always going to be quite that simple, like this question when the numbers might not be so friendly, so to speak. Let's take a look and see what happens here. Rule of cross products says if I multiply that, you get 3x, and then if I multiply these two things, you get 7 times 5 is 35. All right, we look at this right here, we see that 3 is multiplied times x, so we divide it by 3. Okay, and that came out to actually a repeating decimal. If you put it in your calculator, you'll probably see 11.6 repeating. You'll notice at the end of your calculator it becomes a 7, and all the calculator has done there is rounded it off because it really continues forever at that value. So you just say 11.6 repeating. You show the repeating symbol with that bar on top of whatever the pattern is that's repeating. In this case, it's just the 6 repeating over and over again. Bottom of page 10. Again, here's one where we would probably have to get a little help with our calculator again. If we multiply those two things, we get 15. There's an ugly 5. 15 and 4/10 y is equal to, we multiply those two things right there, and we come out with 16.94. And we just go through the steps here. It's that times y, so we divide by 15.4. And we end up, that's all canceled out. You ended up with y over here. That came out to be 1.1. Now, a couple things I'd like to say. I'm trying to model for you again that algebraic form of working downhill. Try to keep your equal signs somewhat lined up, and just basically think of it as that scale we talked about earlier. Like you have a scale and you've got one equation on one side, and you've got another equation on the other side, and you're just keeping it balanced. If you take something off one side, you take it off the other side. As long as you do that, you should be just fine. Let's look at a couple of applications here, and then we'll probably stop it and then come back and wrap it up with some geometry applications here as the end is in sight, but we get into some of the applications. It slows down just a little bit here. But let's look at Donna, the delivery person. Here's what she's done. She drives a delivery van, and she found that she goes 800 miles in 3 days. Okay, well, that's actually a rate, 800 miles per 3 days. At this rate, how far will she go in 15 days? This is a pretty valuable piece of information for a company that uses a car frequently, particularly with the prices of gas. So here's what they've told us, and here's how you'd set this up. Okay, they gave you 800 per 3 days. So I would suggest you just go ahead and write it down right with the labels there. I think that's a really good habit, particularly when you're first beginning. And I wrote that wrong. That's not days, that's miles. She goes 800 miles per 3 days. Did you hear that? That's per. Or in the context of the question, they said in, which could be changed with per. She goes 800 in 3 days. How far would she go in 15 days? Okay, here's the value of writing the labels. Since I see the label that I put days on the bottom over here on the left, then I have to put days on the bottom and the right. And my unknown is that number of miles in 15 days. Again, important information if you're making a budget for these vans. Then you just do your crisscross trick. That's 3 times x, 3x equals 800 times 15, which is 1200. You're almost done, but you have to solve that for 1. Okay, and you do that by dividing by the coefficient of x, which is 3. That becomes 1 right there. You got 1x. 12,000 divided by 3 is 4,000 miles. Is what you could guess that she would go in 15 days. So you then could realize that you're probably looking at about 8,000 miles in a month. So you better be ready to budget for that if you have delivery vans in your business. Okay, let's move along to the fever problem here. In this, if you're a parent and you've ever had to give your kids Tylenol or cough medicine, it can be a scary thing because there's been some scares with some of that medicine in our past. Well, let's say that a doctor suggests that you should give, that a child who weighs 28 kilograms should be given 320 milligrams of Tylenol. If the dosage is proportional to the child's weight, and it's not always that way, sometimes it is, it's not always that way. If it's proportional, how much Tylenol would be recommended for 35 kilograms? So basically, we set this up. It doesn't really matter which number goes on top, as long as you're consistent. You're going 320 milligrams per 28 kilograms. And then you want to know, well, what if my kid, if that's what it says on the box, but what if my kid is 35 kilograms? Now see how I use the labels to know where to put that 35? They have to be across from each other this way on the same level. So we just put an X there, and we're going to crisscross this. 28x, that's equal to 320 and 35, that is 11200. Divide that by 28, and you would have 400 milligrams right there if you did that. Okay, that's a little shorter than the other two, but I'm afraid if I continue going I would run over. The next one is a little bit tricky. So the next video we will finish up an application problem, then we will hit the geometry applications, and you'll be done with chapter 5. Congratulations. We'll talk to you soon.